Hi everyone, welcome to the demo of Georealism framework and its visualization interface Negah. As you can see, Negah consists of four major components, where right in the middle you see the visualization interface that allows users to see the results of the queries that are issued to the system. And the right hand side has the query formulation pane, which basically allows the users to first pick the certain data type that they want to query and then specify the geospatial and the temporal bounds for the query. And for each and every one of these queries that are issued, on the left hand side there is a query layer pane that creates a layer for the results of that query. And finally, at the bottom of the page there are several temporal controls that allow users to navigate back and forth in time for the results of more sophisticated queries. So let's get started, and as our first example we're gonna show you how we can actually query certain data types. So we pick buildings for an example, and we pick circular ranges as our geospatial bound. So we want to see all the buildings that are constructed on USC campus for the period of 7 years, from 2002 to 2009. So these are the results that are returned back, and the interface that actually allows users to pan or navigate or zoom in and back or tilt to get a better view of the query results. Another way of specifying the geospatial bound is by using a user specified trajectory. So as our second example, we're gonna start clicking on different areas of the ground to construct a trajectory and specify a radius of interest. So in this example we pick 1/10 of a mile, and we're going to query photos, for example, that are actually captured and fall within a radius of 1/10 of a mile for that specific trajectory. And for our temporal bounds we specify a period of 4 years, and these are the actual photos that are returned. We've made a fundamental design decision in Negah to allow the interface to be aware of these objects that are returned back as the query result set, and that basically allows the user to further interact with these objects and issue more sophisticated queries. That is very important for the process of decision making. So as you can see in this example, the user can actually pick one of the objects that are returned as the result set and get more information by querying the system for the photo itself or some information about where the photo has been taken. Not only can the users pick these objects to further query them, these objects can actually be used as the input of the second query to query other objects. So as an example, since the interface is aware of these buildings, we can actually pick one of these buildings and use it as the center of a circular range query to return, for example, all the videos that fall within a radius of 1/2 a mile for that certain building. And then we specify a time frame. So for this example we're going to look at all the videos that are captured sometime between March 1st of 2007 to March 2nd of 2007, a period of 2 days, and we hit go. So it returns back the results of 2 videos that are actually captured and satisfy the geospatial and temporal bounds of the user query. The object selection feature can actually be combined with any of these 4 geospatial bounds that you can see on the right hand side. So for example, the user can actually pick 2 buildings and use them as either ends of a range query to query for videos. As our next example, we're going to show you how more sophisticated data types such as moving object trajectories can be queried. So for this example we picked the GPS vehicles. The idea basically here is that all these USC campus and trams and campus cruisers are equipped with GPS devices that allow us to monitor their current and past locations. And what we're going to do right now is to issue a rectangular range query to query for the past locations of all these objects for this given trajectory. So we're going to use this spatial bound and the same temporal bounds as we used for the video query, and these are the results that are returned back. So what is returned back by the system is a set of trajectories for all the trams within that geospatial and the temporal bound specified by the user. Again, since the interface is aware of these result sets, it allows the user to actually pick a certain trajectory and hide the rest of the trajectories to only focus on the location, past locations of a certain tram. So as you can see, the nature of this query result set is highly dynamic. So the temporal controls that you can see at the bottom of the page actually allow the user to move back in time and to pick a certain location in time in the past and to zoom into the data in the temporal domain to get more fine-grained results back for the query. So as you can see, the user picks the right time and starts zooming into the information for the time domain, and we move from a period of several days to a period of several minutes to get a more fine-grained resolution for the data. The time slider can actually be used to move back and forth in time to get the exact location of the tram at any given time in the past. So as the user moves the time slider for any of the vertical bars that you can see for the query layer corresponding to the tram locations, we get the current location of the tram. Note that the temporal controls that you can see at the bottom of the page are not only tied to the result of a single query layer, they can actually be bound to the results of the entire queries that are issued so far in the system, and that allows users to see how the results of several queries change at the same time for multiple occurrences of the time in the past. And this is very critical for the process of decision making, where patterns can be found and decisions can be made based on the results of several queries at several time instances. And so for this example, to show you this concept, we're going to only pick a subset of the layers that we have queried so far, namely the buildings and the video and also the tram trajectory for our specified object, and we're going to go to a subset of time to zoom in that time frame to see how the results of several queries get changed. So by expanding the time duration, we start getting different pieces of the trajectory being drawn on the interface, as you can see in the visualization pane. And by further growing the time as the trajectory gets constructed, you can see a video icon pops up which cues to the user about the existence of a surveillance video that might have captured the tram movement. So let's go ahead and play the video, which further sends another query to the database to retrieve the contents of the video. So as you can see here, the surveillance video has actually captured the movement of the tram and shows an individual hopping into the tram. As we increase the query time frame even further, more parts of the tram trajectory are actually constructed, and a second video pops up at a different location and a different time. The user can actually query the system again to get further information about the possibility of a surveillance camera, and as you can see, we show the same individual actually getting out of the tram. Yes. Alright, so the queries that we have issued so far are actually instances of the so-called fetch query type, where the idea is to return all the objects that fall within a user-specified geospatial bound. Since Negahi is a generic framework that allows interaction with an immersive environment, it actually supports the seamless integration of several other customized query types that are essential for the process of decision making. So an example of such queries in an immersive environment or a 3D virtualized location is a visibility query. So as you can see, the user can actually go and pick a different query type, in our example the visibility query, and again use a circular geobound to color code the entire area based on the points that are visible and are invisible from a user specified query point. So now we can actually hide the other layers and issue this line of sight or visibility query that basically color codes the area based on all the points that are visible from the query point. So by zooming in more, you can see the faces of the buildings that are actually visible from the query point. Alright, with that we're going to conclude the demo. I hope you enjoyed it. Thanks.